In this video, we're going to talk about solving logarithmic equations, and I'm just going to jump right into it. There's kind of like two situations that can happen. So this is the first situation. You've got a logarithm equals a number. And so when this happens, the standard thing to do in this case is to use the definition of the logarithm. So I'm just going to straight up apply this and then see what happens. Now, the only thing I want to mention with this is, so this is log, since there's no log mentioned here, we just assume that this is log base 10. So if I rewrite this expression, then this becomes 10 to the 0.75 equals 3 minus x. And actually, now that I've set this up, right, this is pretty straightforward to solve for x. So I will need a calculator. So let's see, 10 to the 0.75 comes out to 5.62 and some change. And then to finish this, so I can just subtract off the 3, so this becomes 262 equals negative x. And then I get x equals, let's see, x equals negative 2.62. Now, there is one thing that you want to be careful of. So whatever answer that you get, you cannot have, so anything in here always needs to be greater than 0, okay? So in just a quick check, if I were to plug this back in, I have 3 minus 2.62. So I don't have to worry any farther, like, because I can see this is definitely going to be positive. That's just the one thing that you want to check. So it's not, it's okay if you get a negative answer, but you have to check the context that it is in. You could get a positive or a negative answer, and it might not be allowed to go in the logarithm. So that's just a thing to watch out for. Okay, and so here's the other situation that can come up. So I just want to contrast this to the last example. In this example, I have logarithms on each side. And so when that happens, I actually think this is the easier situation. Okay, so the thing that you're going to want to do is you're going to want to use properties of logarithms. So namely, if I'm adding these two logarithms, I can use the product property, which means, let's see, I can rewrite this as 6 times x plus 10. And then I can simplify this as 6x plus 60. Okay, so this is why I say this is easier. When you have a log on both sides, when you have that's even, you can just take out the insides and set them equal to one another. So that is at least nice and straightforward, and then you just do what you do to solve it. So I'm going to subtract the x's. I'll subtract off the 60. So let's see, I get 5x equals negative 40. So then x will equal negative 8. Now again, this isn't a bad thing. I just have to double check for a moment. If I plug negative 8 into this, will it make what's inside the logarithm negative? It will not, so we're good. Okay, so now that I've shown you kind of the basics of this, I think that you should try this on your own. So perhaps you want to pause here, give this one a try. Remember, math is not a spectator sport. Just give it a try. If you get stuck, no problem. You'll understand the explanation a little bit better. Hit play when you're ready. Okay, so this is the situation where I have a log equals a number. So I need to use the definition of the logarithm. And so let's see, 4 to the third is 64. So I have x cubed plus 37 equals 64. So then I can subtract off the 37. So I have x cubed equals 27. And then if I take the cube root of that, 3 cubed is 27. So x will just equal 3. No problem. And just the final check, it's not going to create any problems here. So we're good to go. Okay, so next I have log of x plus log x cubed equals 4. So the hint I want to give here is that you should lean into the properties of logarithms. I have discussed those in another video. Maybe give those a try and then hit play when you're ready. Okay, so once again, I'm going to use the product rule so I can multiply these two parts together. So I have really log x to the fourth equals 4. So check this out. Now I've got to use the definition of a logarithm. So I have 10 to the fourth equals x to the fourth. So I don't even have to go any farther with this, right? I can see what the answer is. So I'm going to have x equals just 10. Now, I do actually want to point something out here. So x equals 10, technically, if I have x to the fourth, so this would be x to the fourth equals 10,000. And normally, when you would take the fourth root of this, since this is an even number, you'd have to have plus or minus that root. That's because it's an even number. But think about the context here. I can't have negative 10 be the answer in this case because remember, what I plug into the logarithm can't be negative. So I don't have to worry about this case. I can just go straight for the positive case. So just something to think about. Okay, so I have another one here. So this is the other type of problem, right, where you have logs on both sides. I would suggest that you give this a try and then hit play when you're ready. So in this case, I am subtracting, which means I can use the quotient property. Oops, let me change my color. So I have log of x squared minus 4 over x minus 2 equals log of 8. And I know that x squared minus 4 equals x minus 2 and x plus 2. So I bring that up because I can cancel out the x minus 2's. So this will become just log of x plus 2 equals log of 8. Cool. So then I'm going to have x plus 2 equals 8, and then I get x equals 6. Okay. So then I just do a quick little mental check. If I plug 6 into this, do I get anything negative here? I don't, so we're good to go. Okay, and so here's just one more for you. So again, I recommend that you just give this a try. If you get stuck, no problem, but the explanation will make more sense to you if you've at least tried it and struggle a little bit with it. Hit play when you're ready. So I'm going to write the left side as log of 5 plus 4x over 3 plus x, because that's the quotient property. Now, in this case, I cannot go any farther with this. I can't simplify, so I've just, this is as far as I can go. But now I can take the insides out of each side of the logarithm. So I can write this as 5 plus 4x over 3 plus x equals 3. And then I have to get rid of the denominator. So I will multiply both sides times 3 plus x so that I can cancel out the denominator. And now I've got 5 plus 4x equals 9 plus 3x. Cool. So now I will subtract off the 3x. I will subtract off the 5. And so I get that x will just equal 4. Okay, and let's see if I think about this. No problem. Nothing negative. So when you do get something that creates a log that is negative, then you do have to be concerned just about, or then you just have to discard the solution. So just always do those checks. Otherwise, that's it for this one, guys. I will catch you in another video.